Jamie Hyneman calls it the Jamie Special.
Yeah, this is a Jamie Special.
A modular steel work table he's used for decades. I gave myself 2 weeks to engineer and build it from scratch. Welcome to Doomsday Protocol. Welcome to Doomsday Protocol, an engineering series where I give myself 2 weeks to take an idea from concept to reality. I'm your host, Big Cons. In this episode, we're building Jamie Hyneman's signature work table. The Jamie Special is Jamie Hyneman's go-to work table that he's been using for decades. It's been talked about multiple times, but the full build process has never been demonstrated until today. If you watched my last video, you know that I often end up working on the ground. As I get older, that's becoming less and less sustainable. Over the next 2 weeks, we'll brainstorm, plan, and execute the Jamie Special together. I'll walk you through every step of the process. So without further ado, let's put 2 weeks on the clock. Here's the problem. There aren't really any plans for the Jamie Special. Jamie's talked about it for years, but there's no blueprint, no cut list, no step-by-step build anywhere. The only thing even remotely close is this OpenSCAD model on Thingiverse, and everything about that is a hard pass.
Pass. Pass? Yeah, pass. Super pass. Uber pass.
If plans did exist, this would be a build video, but they don't. So this is now an engineering problem. So step one wasn't welding, it was research. My first stop was straight into the depths of YouTube and the internet to reverse engineer this thing from whatever scraps of information I could find. From this YouTube video interview, we hear Jamie mention 1-inch square steel tube.
Design. They're steel tubing,
Yeah.
just like we for the shelves, 1-inch steel tubes.
Yeah.
And in another, he discusses setting his motorcycle up on top of it.
You know, you want to put your motorcycle up here and work on it.
Indicating that it's
something
capable
like
of
that.
supporting a pretty decent amount of weight. So instead of copying a table I can't fully see, the goal here is to extract the design principles behind it. Strength, modularity, repairability, and the ability to reconfigure the workspace around the problem, and not the other way around. That means before I touch a welder, I need constraints. Alright, let's define the problem. I'm done building projects on the ground and it's time for a proper workbench. I'm building a Jamie Hyneman-inspired Jamie Special. Here are the constraints. It needs to be 4 by 8 feet and 36 inches tall. It needs to safely support at least 500 pounds. It needs retractable casters, so it can be mobile when I need it and rock solid when I don't. And unlike Jamie's original design, this one will be framed on all sides. It's a structural decision and it keeps the door open for future upgrades. Success means designing and building the entire thing in 14 days. And with that, let's move on to computer-aided design and planning. Alright, so let's take a look at what we got here. So his design typically is open-ended, and as I mentioned, we're going to do a closed on all sides thing. All these welded joints are all T-joints. I think that's part of why this table's so strong. Additionally, as we can see, Jamie Hyneman's table, the underside of the frame doesn't extend to the full length and width of the tabletop. I don't love that design. I mean, I'm sure it's sufficient for what he's doing, and a lot of that is because he's nesting tables. I think we're going to not do that, and we're going to have ours extend to the full 4 foot by 8 foot length. Here I'm opening my Fusion 360 project. I like using a hybrid design workflow because it lets me create assembly-wide parameters which I can then apply quickly to individual parts. Next I'm hopping online to grab the standard dimensions for 1-inch square steel tube, 11 gauge. I went with this size because it's nice and beefy, followed by populating my core design dimensions. Now I'm starting on the table itself. First I create a single leg. This will set the foundation for the whole frame. Next I model the tabletop and use the parameters I created in the original parameter list. With the tabletop in place, I move on to the wide-running support beam. Once I've got one positioned, I use a rectangular pattern to duplicate it across the frame so everything stays evenly spaced. Then comes the long support piece along the length of the table. Again, I model one and use a rectangular pattern to replicate it, keeping the structure consistent. Finally, I create the remaining 3 table legs. Just like before, I use a rectangular pattern to place them in their correct positions. And once more I use rectangular pattern to duplicate the upper structure down to the lower support region, taking care to space it 6 inches from the ground. With that, it's time to move on to the casters. There's a couple different ways we can handle the caster situation. We can go find a caster set on like Amazon and go to their specifications and get rough dimensions for what the products are. The other way to handle this, and I'm really hoping this works out, we can go onto McMaster-Carr and find some casters that are equivalent to ones that we might be able to find on Amazon, or just order the casters straight off of McMaster-Carr. McMaster-Carr can be on the pricey side. I don't know. Let me show you what I'm talking about. So first I try inserting a part directly from McMaster-Carr. While the ability to import CAD directly into the model is convenient, these casters just don't fit the table right. So I follow a suggestion from my friend Brent Hyneman and check out some options on Amazon. These ones are perfect, but I'll need to model them in CAD myself. To plan everything, I start by creating a generic geometry as a placeholder. This lets me see roughly where the casters will go and what adjustments I'll need to make. Thankfully I do this, because I noticed the kickstand on the casters would interfere with the lower support structure. To fix that, I decide to add a 1x2 by 6 inch spacer between the table leg and the casters, giving them the clearance they need and avoiding any conflicts. We got our general design plan done. Now the next steps are materials acquisition, a little bit of a waiting game for those casters, but we can get the ball rolling on getting a cut list together and getting the parts ordered tomorrow. But I think for tonight we've been pretty productive, considering how unproductive the first night was, and man. Anyways, we'll call it for tonight, and I'll see you tomorrow. Day 5 was materials acquisition, which meant a 1-hour drive down the mountain to pick up steel. My original cut list was built around 20-foot stock. The plan was simple: have the supplier cut everything to length and save myself the hassle. That plan lasted about 3 minutes. First problem, they didn't have enough 1-inch 11-gauge square steel tube, so on the fly, I pivoted to 1.5-inch tubing and a slightly thinner wall. Structurally acceptable, but it meant rethinking proportions and weight. Second problem, paying them to make every cut would have been aggressively expensive. 8-foot sections though, those fit in my car, so I recalculated the cut strategy in real time. Bought full 8-foot lengths and decided I'd handle the cuts myself. Bonus, they had an office dog. And on the way back up the mountain, I ran into my beautiful girlfriend and turned the steel run into a coffee date. Materials secured. Before I do anything, I have to recover my welder from up there. Thankfully, I'm able to find a spot from behind the pile of junk where I'm able to climb up and grab it. Next, I start gathering all my measurements and my materials to make sure everything lines up perfectly. To make cutting the steel tubes easier and more precise, I quickly design and 3D print a small bracket. This little tool helps me draw perfectly straight, perpendicular cut lines along the tubes so I can make accurate cuts without guessing. With my bracket in hand, I cut all the steel tube pieces to size. While I'm working, I catch some cool airplanes flying overhead. Always a nice distraction. Then I pull out my sketchbook to double check my assembly plan, making sure every piece goes exactly where it should. The plan first is to weld a square frame, on a flat surface, probably here. Then add the legs, which should be pretty easy because it's just welding them to the corners. Then weld a second square frame. Then weld in the second frame to the first frame using some cut-off blocks at 6 inches. Probably this 2x1 cut off to hold up the piece. So I probably should cut the 2x1 into 6-inch pieces since I got the cutter already and I'm already cutting stuff. Yeah. Now I start assembling the first rectangle for the tabletop. At first I try using a right angle clamp to line up the two pieces, but I quickly realize that I can just lay the bar on the ground and use a T-square to get everything aligned before tack welding. For anyone wondering, a tack weld is just a small temporary weld that holds the pieces in place. I start with tack welds because longer welds can actually pull the metal out of alignment if the joint heats unevenly. Once the first rectangle is tacked together, I continue assembling the other sections. I even get some help from my niece to arrange the general structure. A couple of the tack welds fail, but nothing that stops progress. With everything clamped up, I move on to more complete welds, working on opposite sections to make sure the heat doesn't warp the alignment. I even let my niece have her first runs on the MIG welder, a Harbor Freight unit that I picked up for cheap about 6 years ago that's been surprisingly reliable. I weld into the night, gradually building the structure until it's solid and strong, ready for the next steps. After getting the main structure welded, I head inside for a bit to go over the caster documentation. I figure out exactly where they need to be mounted on the table so everything lines up perfectly. Once I have the measurements sorted, I head back outside, weld the casters in place, and then it's time for the moment of truth, giving the newly mobile table a quick spin.
See how she handles. Oh yeah, dude. This is choice. This thing just moves. Look at that. Beautiful.
The casters roll smoothly, retract perfectly, and it feels great to see it all come together. Day 7 starts with brushing all the welded joints to remove some of the slag. I even experiment with running a drill brush along long sections of the bottom and see that brushed steel texture that I love so much. But I won't be doing that on this table. Still, it looks pretty cool. After brushing all the welds, I apply acetone to the entire structure to remove the black residue that has been getting on my hands during this entire process. Mill scale and leftover flux from welding.
Well, the wheels survived that.
With everything clean, I remember I need to grind and soften all the sharp edges, especially on the surfaces that will contact the tabletop, making sure they're flat and smooth. Once that's done, I re-clean those areas with acetone and finish by applying a clear satin spray paint to the entire structure.
So I don't own a mag drill, which is a problem. It just needs to be rectified eventually anyways. And I hate drilling steel by hand. You can do it, but man, oh man, does it suck. Drill press is always preferable, and so I rigged this nonsense up to drill the holes around the top.
Next, I move on to drilling the holes in the top beams. I start by marking all the points, spaced 1 foot apart, which will make them really useful reference points when using the table later. Once the marks are set, I center punch each one to keep the drill bit from wandering. Then, using my makeshift stack of bricks to support the drill press, I go through and drill all the top holes with a stepper bit. When drilling steel, it's important to use cutting oil and drill at a low RPM.
All right.
After that, I switch to a 1/4 inch drill bit to punch down through the top holes and drill out the bottom holes in the square steel tube. This ensures everything stays straight and perfectly aligned. After drilling the final hole, I pack it up for the night and get ready to put a top on this bad boy tomorrow. Day 8 starts with a trip to pick up a sheet of 1/2 inch plywood. After getting it back to the shop, I spend some time carefully aligning it on the frame and clamping everything into place. Using the holes I already drilled in the steel tube as guides, I drill up through the tabletop with a hand drill, making sure everything lines up perfectly. Once the holes are through, I come back with a countersink bit and remove just enough material so the 1/4 flathead screws will sit perfectly flush with the surface. Then it's time for assembly. Each hole gets a screw, washer, and locking nut. I work my way around the table, tightening everything down until the final fastener goes in. Ready to see how this turned out? And that's it. We made it. The Jamie Special is finished, designed, fabricated, and assembled in less than 2 weeks. Along the way, we adapted the design, solved problems on the fly, and proved that sometimes the engineering process matters more than the perfect plan. This thing is solid, modular, and finally gets me off the floor, which honestly was the whole point. Thanks for following along for the build. The clock resets now, and the next protocol starts soon. Until then, stay frosty.